Hey everybody, in this video I'm going to go over how I stabilize wood, how I prepare the wood, how I dry the wood, the products I use, and I'm not being paid for this. The companies are not compensating me in any way because most of this shit I'm repurposing for other things to do what I need to do because that's how you got to do it. Come on. Daylight's burning, let's get on it. Alright, wood prep. You gotta saw this down into handle size blocks. First, as you can see, it's not anywhere being handle size or handle shape, so I have to trim it. And that's what we'll do first. And I'll use my fence. So now that we've got a straight edge, I can saw this into handle-sized blocks. You want to go a little bigger because this is going to dry down to 0% moisture. So you want to, this your handle size, you want to go, oh, I don't know, maybe an 1/8 of an inch bigger. Allow for a little bit of shrinkage. And again, you want to go a little thicker than your finished size to allow for shrinkage when it dries, because it will shrink. So now we'll cut them to length.
Oh crap.
Square the end, push it all the way to the stop, cut it off. There you go, 4 handles. This wood has been drying for about 6 months now, just air dry, and we'll put a moisture meter on it and see what kind of moisture content we've got on it. There's about 14% moisture in that piece of wood, and that will not stabilize well. Although the water will boil off under vacuum, you can get water to boil at room temperature under a vacuum. It will come out, but it'll cause problems in your pump. The more stuff that pump pulls through it, the more problems you're going to have. That's why you got to get that good and dry. I'm going to show you how I dry my wood. I use an electric smoker that I've got set up with a oven tamer that's sold by Turntex Woodcraft, and it's got a PID controller, and you can see it's my set point's at 185 degrees and it's reading 47 degrees. This is a thermocouple. I've got it hooked on that bottom rack so it reads the temperature about 12 inches above the heating element. And then up here I've got a electric fan that circulates the air so it doesn't get any hot spots. I'm gonna set this to dry wood. You want to set that at 220 so you're above the boiling temperature of water. That's 212 for metric friends. So that'll come up to temperature, and I'm going to load the wood in it and show you how I do that. And I'll just fill it up. Fill it totally full. And then once that oven tamer gets the temperature up, it'll start throttling the heating element. And this is your output. That means you got that little red dot right here by my finger. It means you got power going to the element. And when it gets close to that temperature, it'll start going on and off. So I'll let this wood dry for a minimum of 24 hours. Generally it goes longer, because once I get a batch of it in the vacuum chamber, I'll load this up. It comes out of the vacuum chamber, and then it'll go in here. I'll unload this, put it in the vacuum chamber, so I'm always trying to roll wood through. It can be in here a week, 2 weeks, 3 days, 4 days. And these are my ammo cans that I use to store the dry wood in. They've got a rubber gasket on the lid, so they're airtight. So once your wood is dry, you put it in there, close the lid, and it won't draw any moisture. After you pull all the moisture out of this by drying it at 220 degrees for a minimum of 24 hours, you need to put it in a airtight container and let it cool down. It has to be airtight because as it cools, it's going to draw moisture in from the atmosphere. So I just got some 50 caliber ammo cans with the rubber seal on them so it's airtight, and when it's cooled down, we'll go into the vacuum pot. And get the stuff going. So what I've got is a 5-gallon paint pot to use as my chamber, and then my container is just a 5-gallon bucket. And I'll stack that wood in there as tight as I can, so I'm not using a lot of juice in the process. See that all those voids right there, that void and that void, that's going to fill up with liquid, and if you have too many of those, you're wasting a lot of your juice. So I try to get them packed in there as tight as I can. I mean, you're really putting a square peg in a round hole when we're doing this, but you want to try to limit
those voids as much as you can. And that's what always happens. You get that one stubborn fucking piece that when you're in there.
Let's talk about vacuum. Vacuum is the absence of pressure. The maximum vacuum you can pull at sea level is 30 inches. And here where the shop is, we're at about 1,000 feet in elevation, and our maximum vacuum we can pull is 29.2 inches of mercury. It is what it is. You cannot pull more than 30 inches because all that measurement is the lack of pressure. So we all live under 1 atmosphere of pressure, and that is 14.5 psi. And all that is a measurement of the air column from ground level to outer space.
We need to seal this up, and you got a good gasket surface right there, and I've got a steel ring that I made and a rubber gasket to go on that, and then your glass lid. Now this is important because you've got to be able to see down in there to watch your bubbles, and what you're doing is removing all the air out of that piece of wood. So when you let the vacuum off of it and put your atmospheric pressure back on the top of that liquid, the 14.5 psi that we all live under shoves that cactus juice into the voids that were filled with air, and now it's going to be filled with the resin. And you have to limit your vacuum at first, otherwise it foams up, and if that juice gets up into that pump, it causes the pump to go out. So you want to keep those bubbles and all that foam down from your port. So now we've got that foam mostly knocked down, and it's on its way to full vacuum. Now for our elevation, we're about 29.2 inches of mercury will be full vacuum. You can only pull 30 inches of vacuum if you're at sea level. And once you start going up, the vacuum goes lower, or it won't go to 30 inches. All you're doing when you're pulling this vacuum is taking atmospheric pressure off the chamber. And this will set like this for days until the bubbles stop. It's not a quick thing. And I've got a lot of wood in there, so there's a lot of air being sucked out of there. This is my vacuum pump. It's a rotary vane vacuum pump, and this is a high displacement pump. So that means it moves a lot of air or gas. This type of pump is typically used in chemical factories for pulling vacuum on chemical reactions. and here we're just pulling vacuum on a 5-gallon bucket.
Okay, so this has been under vacuum for about 4 days, and it's slowed down enough to where I'm going to say the bubbles have stopped. For what I'm doing, I think that I don't need to get 100% of that stuff out of there. I haven't had any issues with wood moving around, and I've gotten very good results with what I'm doing, so if it ain't broke, I'm not going to fix it. We'll let this off now and close. Now what that'll do is we're putting atmospheric pressure back on that juice that was under vacuum, and because it's submerged in that liquid, it's going to come back to pressure, and that'll shove that cactus juice into the voids where there was air. Now that the pressure's off, you can see that I've got a weight in there so the wood doesn't float. You have to follow your process. Follow your cake recipe. You stick with that recipe and you'll have good results. This was under vacuum for 4 days, so I'll let it set for 8 days. So it's been about a half an hour since I've taken that vacuum off of the juice in the wood, and you can see how much juice that wood has taken up in just that first 30 minutes. And this is why you want to overfill your chamber and keep as much liquid above that as you can, because once you take that off, it is going to suck up a tremendous amount of cactus juice.
We just finished soaking the wood in the cactus juice. Now it's got to be baked, because this stuff hardens up when it reaches 185 degrees. That's what catalyzes epoxy, is the heat. This is how I bake resin impregnated wood. That comes out of there and it's hard. 185 degrees until it's done. That holds that temperature exactly where you have it set. The set point's in green, and the actual reading of the temperature is in the red.
This is my chemical storage that I use to store my juice. As you can see, I've got several gallons of colored juice that I use to dye the wood.